Now, in this lecture, we find out the length of line segment X. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. And we know that AO, line segment AO, equals to 10 units in its length. And our mission is to find out the length of this line segment AM, that is equal to X. So, first of all, because of the fact that AOB is a quarter circle, it means that this angle is a right angle, it is equal to 90 degrees. And AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10 units, therefore OB equals to also to 10 units. But the radius of this quarter circle OB is also the diameter of this semicircle. So the diameter OB equals to 10 units, and therefore the radius of this semicircle will be equal to 5 units. We define the center of this circle as point P. Therefore, the radius OP of this quarter circle equals to 5 units. Here, PB is also the radius of this quarter circle, therefore it is equal to 5 units in its length. And AM, tangent AM is tangent to this semicircle at this point. We define the point of tendency of tangent AM in this semicircle as Q. In the next step, we will join points P and Q together by a straight line. So point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units. And we have here the radius PQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then according to rule number 1, tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Okay? Here, point A is a common extra point in relation to this semicircle. Why? Because point A is not located inside this semicircle, no, on this semicircle, but it is located outside of this semicircle. Therefore, point A is an extra point in relation to this semicircle. And from point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, the lengths of two tangents from a common extra point to a circle are equal. So from the common extra point A, we have two tangents, tangent AO and tangent AQ. And according to rule number 2, they must be equal to each other. That is to say, AO equals to AQ. But AO is 10, therefore AQ must be also equal to 10 units in its length. Okay? In the next step, we will extend the tangent AM and also will extend side OB by a straight line until they touch each other. And we define the touching point of those two extended line segment OB and AM as N. by doing this construction, we created here the right big triangle, triangle AON. So we define angle ANO of this right big triangle as theta. And we'll focus on the right big triangle, triangle AON. In the right triangle AON, this angle equals to theta according to our definition. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we'll focus on the right triangle QPN, on the right small triangle QPN. In the right small triangle QPN, this angle equals to theta. This angle equals to 90 degrees. Therefore, this missing angle must be equal to 90 degrees minus theta. In the next step, we'll prove that the right big triangle AON is similar to the small triangle, triangle QPN. Small right triangle, triangle QPN. Okay. Okay, again, we prove that the right big triangle, triangle AON is similar to the right small triangle, triangle QPN. This triangle QPN. So, the green triangle is triangle QPN. So, why the green triangle is similar to the right big triangle, triangle AON? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big right triangle AON. And it is equals to this angle in the small green triangle, triangle PQN. So this is angle PQN. Repeat again. Angle AON in the right big triangle AON is equals to angle PQN in the small green right triangle, triangle PQN. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles. So angle theta equals to itself, it's a common angle. So if we relate to angle theta as it belongs to the big right triangle, triangle AON, it will be angle ONA. And if we relate to this angle theta as it belongs to the small green right triangle, triangle PQN, it will be angle PNQ. Repeat again. This equation means that angle theta equals to itself as a common angle that belongs to both triangles. So if you relate to angle theta as it belongs to the right big triangle AON, it will be angle ONA, and it is equals to angle theta itself. If we relate to angle theta as it belongs to the small right green triangle PNQ, it will be angle PNQ. So angle theta is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle OAN in the big right triangle, angle OAN, and it is equal to this angle in the small green right triangle. It is actually angle NPQ. Repeat again. Angle OAN in the big right triangle equals to angle NPQ in the small green right triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right big triangle AON are correspondingly equal to all the three angles in the green small right triangle PQN. Therefore actually proved that the right big triangle AON is similar. This is the sign of similar to the right green small triangle PQN. Therefore, we actually proved that those two right triangles are similar to each other according to angle similarity rule. Okay, are similar to each other according to angle similarity rule. And from the fact that the green triangle is similar to the right big triangle AON, we will derive that the following relationship exists between their sides. We will derive that AO in the big right triangle AON, side AO over side PQ, the small green right triangle, P and Q. So it is AO over PQ equals to AN in the big right triangle ANO over PN in the small green right triangle PNQ. Again, we derive that AO over PQ equals to AN over PN, and it is also equals to ON in the big right triangle AON over QN. Repeat again. We derive that AO over PQ equals to AN over PN equals to ON over QN. Okay. AO is 10 over PQ is 5, and it is equals to AN equals to AQ plus QM. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN over PN. PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. Again, we found out that 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is also equals to On over Qn. So it is On equals to OB plus Bn. OB is the diameter of the semicircle, that is 10, 5 plus 5 is 10, plus Bn. So in total, On equals to 10 plus Bn. 10 plus Bn over Qn. Again, in conclusion, we found out that 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is equals to 10 plus Bn over Qn. Those two expressions are equal to each other, so therefore we create from those two expressions that are equal to each other equation number 1. So according to equation number 1, we have 10 over 5, that is 2, and it is equals to 10 plus Qn over 5 plus Bn. So according to equation number 1, we found out that 2 equals to 10 plus Qn over 5 plus Bn. Those two expressions are also equal to each other, so we'll create from those two expressions that are equal to each other equation number 2. So according to equation number 2, 10 over 5 is 2, and it is equals to 10 plus Bn over Qn. Repeat again, according to equation number 2, we found out that 2 equals to 10 plus Bn over Qn. Here we'll multiply equation number 1, this equation number 1 by 5 plus Bn, and we get that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. It again, we found out that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn. Here we'll open the brackets on this side of the equation number 1, and we get that according to equation number 1, 2 times 5 is 10, so 10 plus 2 times Bn is 2Bn, and it is equals to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 we get cancelled. So after we cancel 10, we left only with 2Bn that is equal to Qn. So according to equation number 1, we actually found that the Qn equals to 2 times Bn. Okay, Qn equals to 2 times Bn. This is according to equation number 1. While according to equation number 2, we have already found out that two equals to, according to equation number 2, we have already found out that 2 equals to 10 plus Bn over Qn. We multiply this equation number 2 by Qn, and we get that according to equation number 2, 2 times Qn equals to 10 plus Bn. Now we'll put the value here. We know that Qn equals to 2 times Bn. According to this equation number 1, Qn equals to 2 times Bn. Therefore, we substitute Qn in this equation number 2 by 2 times Bn. We'll do it now, we'll get that according to equation number 2, 2 times Qn, as Qn is 2 times Bn. It is equals to 10 plus Bn. We substitute Qn in this equation number 2 by 2 times Bn from equation number 1. Because Qn equals to 2 times Bn. So we found out that according to equation number 2, 2 times 2bn is 4bn, so 4bn equals to 4 times bn equals to 10 plus bn. Here we subtract bn from this equation number 2, and we get that according to equation number 2, 4 times bn minus bn is 3bn, and this equals to 10. So according to equation number 2, 3 times bn equals to 10. We will divide this equation number 2 by 3, and you get that according to equation number 2, bn equals to 10 over 3. Okay, so bn equals to 10 over 3 units. So you can write down in the original drawing that this line segment bn equals to 10 over 3 units. And we have already found out that according to equation number 1, qn equals to 2 times bn. So write it down. According to equation number 1, we found out that qn equals to 2 times bn. And we just right now found out that bn equals to 10 over 3. So we'll put the value of bn inside this equation number 1, and we get that qn equals to 2 times bn, and bn is 10 over 3, so it is 2 times 10 over 3. So in conclusion, we found out that according to equation number 1, qn equals to 2 times 10 is 20, so this expression in total equals to 20 over 3. In conclusion, we found out that qn equals to 20 over 3 units in its length. So you can write down in the original drawing that qn, this is qn, I say that qn equals to 20 over 3 units in its length, and bn equals to 10 over 3 units. In the next step, we will define side QM, line segment QM as A. So QM is A. What is the length of MN? The length of line segment MN, from the drawing, it is very easy to see that MN equals to QN minus QM. Again, MN equals to QN minus QM. Repeat again. From the drawing, it is very easy to see that MN equals to QN minus QM. So MN, the length of line segment MN, is equals to QN. QN is 20 over 3 minus QM. QM equals to A according to our definition. So in total we found out actually that MN equals to 20 over 3 minus A. So you can write down in the original drawing that MN equals to 20 over 3 minus A units in its length. Okay. In the next step, we'll complete this quarter circle to a circle. So we actually completed this quarter circle to a circle, and we will extend side BO by straight line until it touches the circle. And we'll define the extended side BO, the touching point of the extended side BO with this circle as C. So actually point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of this circle. The radius of this circle OC equals to 10. Why? Because the radius of the circle and the radius of the quarter circle are the same. Okay? We just completed the quarter circle to a circle. Okay? So the radius of the circle must be also equal to the radius of the quarter circle. Therefore, the radius OC equals to 10 units. That is also the radius of the quarter circle. In the next step, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14 is true in any circle. So in any circle, if we draw two chords A, B and C, D from the common external point P, then the following equation will be true, that PA times PB equals to PC times CD. So we have here a circle, and we have here point P, that is an external point in relation to this circle, because point P is not located inside the circle, nor on the circle, therefore it is located outside the circle. Therefore point P is defined as an external point in relation to this circle. So from the current external point P, if we draw line segment PB, actually that cuts the circle at 2 points, A and B. In this way, created chord AB. Then from the same common external point P, we'll draw another line segment that cuts the circle at point C and D. In this way, we actually created chord CD. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So whenever you draw from a common external point two line segments, that cuts the circle at 2 points, like here, this line segment PB cuts the circle at points A and B, and this line segment PD cuts the circle at points C and D. In this way, created chord AB and chord CD. And in this drawing, the following equation is true, that PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing. Why? Because in our drawing, if we focus on the common external point N, from the common external point N, we have a line segment NC that cuts the circle at points B and C, and we have also line segment NA that cuts the circle at points M and A. So all the requirements of rule number 14 are met. Therefore, we can implement here rule number 14. Repeat again, we'll focus on the common external point N. From the common external point N, we have line segment NC and line segment NA. Both of them cuts the circle at 2 points. Therefore, all the requirements of rule number 14 are met. Can implement rule number 14. According to rule number 14, we get that NB times NC equals to NQ times NA. Okay, again, NQ times NA. Repeat again. In our drawing, if we focus on the common external point N, all the requirements of rule number 14 are met. Therefore, according to rule number 14, we get that NB times NC equals to NQ times NA. Okay. So NB is 10 over 3 times NC. What is the length of line segment NC? NC equals, or CN equals to CO plus OB plus BN. Again, CN equals to CO plus OB plus BN. So CN equals to CO, that is 10, plus OB, that is 5 plus 5, that is also 10, plus Bn, that is 10 over 3. So in total, Cn or Nc equals to 10 plus 10 plus 10 over 3. Okay, repeat again. Nq, Nc in total equals to, or Cn equals to 10 plus 10 plus 10 over 3, and it is equals to Nq. Nq is 20 over 3 times Na. Na it is actually equals to Nm. Repeat again. According to rule number 14, Nb times Nc, Nb times Nc equals to Nm times Na. So it is Nm times Na. Repeat again, according to rule number 14, if you focus on the common external point A, point N, Nb times Nc equals to Nm times Na. Nb is 10 over 3, Nc is 10 plus 10 plus 10 over 3, and it is equals to Nm. What is the length of Nm? We already found out that Nm equals to 20 over 3 minus A. So Nm is 20 over 3 minus A times Na. What is the length of Na? Or An? An in total equals to Aq plus Qn. That is to say, An equals to Aq, that is 10, plus Qn, that is 20 over 3. Okay. In total, An equals to 10 plus 20 over 3. In conclusion, we found out that according to rule number 14, 10 over 3 equals to 10 plus 10 plus 10 over 3, and it is equals to 20 over 3 minus A times 10 plus 20 over 3. So 10 over 3, here we have 10 plus 10 is 20, so it is 20 over 10 over 3, and it is equals to here 20 over 3 minus A. We multiply minus A by 3 and then we divide it by 3 in order to have a common factor with this expression, and we get that this expression will be equal to, in total, to 20 minus 3A over 3 times 20 plus 10 plus 20 over 3. We'll multiply 10 by 3 and then we'll divide it by 3 in order to make a common factor with this expression. And we get that 10 times 3 is 30 and 30 plus 20 is 50. So in total this expression equals to 50 over 3. In conclusion, found out that 10 over 3 times 20 plus 10 over 3 equals to 20 minus 3a over 3 times 50 over 3. So 10 over 3, here we will multiply 20 by 3 and then we divide it by 3 in order to a common factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70, so in total in the numerator we have 70 over 3 and it is equals to 20 minus 3a over 3 times 50 over 3. So on both sides of the equation we have in the denominator 3 times 3. 3 times 3 is 9. So we'll multiply this equation by 9 in order to eliminate the denominator. Because we have on both sides of the equation 9 in the denominator. And we get that according to this equation, so here we cancel the denominator of 3 times 3 and we're left only with 10 times 70 in this side of the equation. And it is equals to 20 minus 3a times 50. Here the denominator of 3 times 3 is cancelled because we multiplied this equation by 9. In conclusion, found out actually that ten times 70 equals to 20 minus 3a times 50. We will divide this equation by 10. So here 10 will get cancelled and we left in this side of the equation only with 70. And that equals to 20 minus 3a and 50 over 10 is 5. So 70 equals to, we'll open the brackets on this side of the equation. 5 times 20 is 100. Minus 3a times 5 is minus 15a. So here we subtract 70 from this equation and we get that 0 equals to 30 minus 15a. We'll add to this equation 15a and we get that 15a equals to 30. We divide this equation by 15 and we get that a equals to 30 over 15 is 2. So a equals to 2 units in its length. So here this line segment A equals to 2 units in its length. And our mission is to find out the length of AM, that is x. So x equals to AM. Here x equals to AM. And AM equals to AQ plus QM. AM equals to AQ plus QM. Repeat again. According to what is given us the question, x equals to AM. And from the drawing it is very easy to see that AM equals to AQ plus QM. That is to say, this equals to AQ, that is 10, plus QM, that is A. So x equals to AM equals to 10 plus A. So x equals to 10 plus A, and A is 2. Yeah, A is 2. So in total, x equals to 10 plus 2, that is 12. So x, that is equal to AM, equals to 12 units in its length. And that is the answer to the question. In the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM, is equal to x according to what is given as the question. So in the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have this semicircle. We know that side AO equals to 10 units in length, and our mission is to find out the length of this line segment AM that is equal to x according to what is given as the question. So first of all, this is AOB. AOB is a quarter circle, therefore this angle must be equal to 90 degrees. And side AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB must be also equal to 10 because they are both the radii of this quarter circle. And then, so OB, that is the radius of this quarter circle, equals to 10 units in its length. But the radius OB is the diameter of this semicircle. So we know that the diameter of this semicircle OB equals to 10. If the diameter of the semicircle is 10, then the radius must be equal to 5. So the radius OP equals to 5, and the radius PQ of this semicircle equals to 5 units in its length. We define the point of tendency of tangent AM with this semicircle is Q. Point P, we define the center of this semicircle is P, and we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle that is equal to 5 units in its length. So here we have the radius PQ is drawn to the point of tendency. That is to say, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Okay? Then we focused on the common external point A. From the common external point A, we have tangent AO and tangent AQ to this semicircle. And according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. That is to say, AO equals to AQ, but AO is 10, therefore AQ must be also equal to 10. Okay, then we extended AQ and OB by straight line until they touch each other. We define the touching point of the extended AQ and OB as N. Okay, this way we actually created the big right triangle AON. Then we defined angle A and O as theta, and we focus on the right big triangle AON. In this big right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, according to the same logic, in the right triangle PQN, the right green triangle PQN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Then we proved that the green small right triangle PQ is similar to the big right triangle AON. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so we can say that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the big triangle AON are correspondingly equal to all the three angles in the small right green triangle PQN. Therefore, we actually proved that the right big triangle AON is similar to the right small green triangle PQN according to angle similarity rule. Okay, and from the fact that the green triangle PQN is similar to the right big triangle AON, we will derive that the following relationship exists between their sides. We will derive that AO, side AO in the big triangle over PQ in the small triangle equals to AN in the big triangle over PN in the small triangle, and it is equals to ON in the big triangle over QN over in the small triangle. AO is 10, PQ is 5, AN, what is the length of AN? AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10 plus QN. So in total, AN equals to 10 plus QN. Here, AN equals to 10 plus QN over PN. What is the length of PN? PN equals to PB plus BN. Again, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. Here, PN equals to 5 plus BN. PN equals to 5 plus Bn, and it is equals to On. What is the length of On? On equals to OB plus Bn. OB is 5 plus 5, that is 10, plus Bn plus Bn. So in total, On equals to 10 plus Bn. Yeah. On equals to 10 plus Bn over Qn. Qn is the missing side, so we leave it as it is. So in conclusion, found out that 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is equal to 10 plus Bn over Qn. Those two expressions are equal to each other. Therefore, we created equation number 1 from those two expressions that are equal to each other. So this is equation number 1 that says that 2 equals to 10 plus Qn over 5 plus Bn. Those two expressions are also equal to each other. So we created equation number 2 from those two expressions that are equal to each other. According to equation number 2, 10 over 5 is 2, so 2 equals to 10 plus Bn over Qn. This is equation number 2. Then we cross multiply this equation number 1, and found out that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. I repeat again, according to equation number 1, we actually found out that 2 times 5 plus Bn equals to 10 plus Qn. We open the brackets on this side of this equation number 1, and found out that 2 times 5 is 10, plus 2 times Bn equals to 10 plus Qn. Here we have 10 on both sides of the equation, so 10 we get cancelled. After we cancel 10, we left in this side of the equation only with 2 times Bn, that is equal to Qn. So according to equation number 1, we actually found out that Qn equals to 2 times Bn. While according to equation number 2, we have already found out that 2 equals to 10 plus Bn over Qn. We multiplied this equation number 2 by Qn, and found out that 2 times Qn equals to 10 plus Bn. So here we substitute Qn by 2 times Bn. Why? Because according to equation number 1, Qn equals to 2Bn. So we substitute Qn by 2 times Bn. Qn is 2 times Bn, and it is equals to 10 plus Bn according to equation number 2. So 2 times 2Bn is 4Bn, and it is equals to 10 plus Bn. Here we subtracted from this equation number 2 Bn, and found out that 4 times Bn minus Bn is 3 times Bn. So 3 times Bn equals to 10. We divided this equation number 2 by 3, and finally found out that Bn equals to 10 over 3 units in its length. This line segment line segment Bn equals to 10 over 3 units in its length. This is according to equation number 2. While according to equation number 1, we have already found out that Qn, according to equation number 1, we have already found out that Qn equals to 2 times Bn. That is to say, Qn equals to 2 times Bn, but Bn is 10 over 3. So we put the value of Bn inside, Bn inside this equation number 1. So Q1 is 2 times Bn is 10 over 3, so it is 2 times 10 over 3. That is to say, Qn total equals to 2 times 10 over 3, that is actually 20 over 3. So in conclusion, found out that Qn equals to 20 over 3 units in its length. This line segment Qn equals to 20 over 3 units in its length. Okay, then what is the length of Mn? Here, first of all, we define line segment Qm as A. So what is the length of Mn? From the drawing it is very easy to see that Mn equals to Qn minus Qm. I'm repeating again. From the drawing it is very easy to see that Mn equals to Qn minus Qm. Qn is 20 over 3 and Qm is A according to our definition. So in conclusion, found out that Mn equals to 20 over 3 minus A. Here this line segment Mn equals to 20 over 3 minus A. Then I presented to you rule number 13 and implemented rule number 13 in our drawing. Rule number 14, I presented to you rule number 14 and implemented rule number 14 in our drawing. According to rule number 14, that is true in any circle, if we have the common external point P, and the common external point P, we draw here two line segments, line segment PB and line segment PD. The first line segment PB cuts the circle points A and B, in this way created called AB. The second line segment PD cuts the circle points C and D, in this way created called CD. So in this drawing, the following equation is true. That PA times PB equals to PC times CD. Again, PA times PB equals to PC times PD. So whenever you draw from a common standpoint, two line segments that cut the circle at 2 points, at 2 different points, you can implement rule number 14. So in our drawing, we have the common external point N. From this common external point N, we have line segment NA that cuts the circle points M and A. And we have also line segment NC that cuts the circle points B and C. So we have a common external point, and from the common external point we have two line segments that cut the circle at 2 different points. Here the line segment NA cuts the circle at points M and A, and the line segment NC cuts the circle at points B and C. Therefore, all the requirements of rule number 14 are met, and for that reason you can implement here rule number 14. According to rule number 14, we get that NB times NC equals to NM times NA. Repeat again. According to rule number 14, we get that NB times NC equals to NM times NA. NB is 10 over 3 times NC. What is the length of NC? The length of NC is CO plus OB plus BN. CO is 10, OB is 5 plus 5, and BN is 10 over 3. So in conclusion, CN equals to 10 plus 5 plus 5 plus 10 over 3. Or 10 plus 5 plus 5 is 10, so it is 10 plus 10 plus 10 over 3. Repeat again. In total, NC equals to 10 plus 10 plus 10 over 3, and it is equals to NM. We already found out that NM equals to 20 over 3 minus A. Here, NM equals to 20 over 3 minus A times NA. What is the length of NA? AN equals to, in total, to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. I'll repeat again. AN in total equals to 10 plus 20 over 3. So here we have 10 plus 10 is 20. So in total, this expression equals to 20 plus 10 over 3. Here we multiplied minus A by 3, and then we divided by 3 in order to account factor with 20 over 3. So this expression in total will be equal to 20 minus 3A over 3. Here we multiplied 10 by 3, and then we divided by 3 in order to have a common factor with 20 over 3. So this expression in total will be equal to 50 over 3. And here we multiply 20 by 3, and then we divide it by 3 in order to have a common factor with 10 over 3. So 20 times 3 is 60, so 60 plus 10 is 70, so in total in the numerator we have 70, in the denominator we have 3. So this expression in total equals to 70 over 3. And there we have 20 minus 3A. After we multiplied A by 3 and then we divided by 3, this expression in total equals to 20 minus 3 over 3. And this expression after we multiplied 10 by 3 and then we divided by 3, in total equals to 50 over 3. So we have here 9 in the denominator on both sides of the equations. Therefore we multiplied this equation by 9 in order to cancel the denominator 9. Okay, you multiply this expression by 9 in order to cancel the denominator 9. And found out actually that so we cancel 9 in the denominator, we left only with 10 times 70 equals to 20 minus 38 times 50. Here we divided this equation by 10, 10 over 10 is 1, and 50 over 10 is 5. So in total 70 equals to 20 minus 3a over 5. Then we open the brackets in this side of the equation and found out that 70 equals to 25 is 100, minus 3a times 5 is minus 15a. So in total we found out that 70 equals to 100 minus 15a. We subtracted 70 from this equation and found out that 0 equals to 30 minus 15a. We added 15a to this equation and finally found out that 15a equals to 30. Here we divided this equation by 15 and found out that a equals to 2. Here a equals to 2. This line segment Q M is equals to a and a equals to 2. And what is we are looking for the length of AM that is equal to x. From the drawing it is very easy to see that AM equals to AQ plus QM. We are looking for x that is equal to AM, and AM equals to AQ plus QM. AQ is 10 and QM is 8. So in total AM equals to 10 plus A. And A is 2, so AM, that is x, in total equals to 10 plus 2, that is 12. So in conclusion, found out that the length of line segment AM that is equal to x, it is equals to 12 units in its length. Okay? That's all to the question that the length of line segment AM, that is x, it is equals to 12 units in its length. Okay, thank you very much.